Today, as we start Unit 4, which is our linear functions unit, we are going to start by having this pre-lesson where we are going to learn how to recognize and apply ratios and percents to real-world situations. This is stuff that we have learned in years past in other math classes, but we just want to review it real quick so we could use these skills throughout this unit. So, what is a ratio? Ratios compare values. A ratio says how much of one thing is compared to how much of another thing. For example, if we look at this first diagram that's written there, it says there are 3 blue squares to 1 yellow square. Ratios can be shown in a variety of ways, such as we could use exclamation points to separate the values. So we can say 3 exclamation point 1, meaning 3 to 1. We can also say this to that, so 3 to 1. Or we can write it as a fraction and say 3 divided by 1. A ratio can also be scaled up, so if we have a ratio 3 to 1 and we want to know about how much, if we have 6 blue, then we could just multiply both by 2 and we could say 6 to 2. So, yeah, that is a ratio. Now, what is a proportion? A proportion states that two ratios are equal. For example, we could have the ratio 1 to 3 is equal to 2 to 6, because those are the same ratios, just multiplied by 2. To solve for the missing value of proportions, we can simply cross-multiply. So let's solve the following proportions here. Number 1, we could cross-multiply. X times 9 is just 9x. And 3 times 6 is 18. This is a simple one-step equation. To get rid of 9, since it's being multiplied, we divide. Cross that off. We would have x equals 2. All done. So that means 2 to 6 is the same as 3 to 9. Let's look at the next one. 36 times 4. I don't remember that off the top of my head. That'll be 144 equals 9 times y, which is 9y. Now to get rid of the 9, we divide on both sides. We would get y equals 144 divided by 9 is 16. Good. And let's look at number 3. 9 times 20 is 180, I think. 9 times 20. Yep, 180 equals 12 times x. 12x. Divide both sides by 12. X equals 15. Good. Perfect. Alrighty. So that is how we find missing values in a proportion. We use cross multiplication. Now, let's go over some word problems. This person owns a music store. He needs 2 supervisors for every 5 trainees. So, that means that we're going to write 2 over 5. Remember, on the top is the number of supervisors, on the bottom is the number of trainees. If 30 new trainees, 5 trainees, so we need to put 30 at the same level of the fraction as the 5. So it would go at the bottom. How many supervisors? Supervisors are unknown, so I could put S on top for supervisors. All right, now 2 times 30 is 60, and 5 times S is 5S. Divide both sides by 5, S equals 12. Meaning that for 30 new trainees, he would need 12 supervisors. Good. Let's look at the next one. The ratio of boys to girls in a class is 3 to 5. So this means 3 boys to every 5 girls. I just put the units here because I want to remember. Equals. If there are 25 girls in the class, girls are at the bottom of my fraction, so I'm going to put the 25 there. How many boys? Boys are unknown, so I'll just put a B. All right, let's cross multiply. 3 times 25 is 75, and 5 times B is just 5B. divide both sides by 5. We get B equals 75 divided by 5 equals 15. Meaning, for 25 girls, there would be 15 boys. Nice. All right, let's look at the next one. Comparing fractions, percents, and decimals. Converting fractions, percents, and decimals. So if you start out with a fraction and you want to get a percent, you would times the fraction, you would divide the fraction, then times it by 100, and simplify. And then you add the percent symbol. That way everybody knows it's a percent. So fraction to percent, you divide it, so you'd end up getting like a decimal, and then you times it by 100. Now a percent to a decimal, you would divide the percent by 100 and move the decimal, or you can move the decimal 2 places to the left. Now if you want to go the other way, if you want to get a decimal to a percent, you times by 100 and you move the decimal 2 places to the right. If you want to get a percent to a fraction, you would put the percent over 100, remove the percent sign, and simplify. All right, let's look into this. Write the percent as a decimal, 23%. So we're going from a percent to a decimal. Let's look at the directions. Percent to decimal is right here. We would divide by 100 or move the decimal place 2 places to the left. So 23%, remove the decimal, divide it by 100, remove the percent symbol, divide by 100, we get 0.23. 23 divided by 100. Good. Or you could also take the 23, remember there's a decimal at the end of it, and move that decimal place 2 places to the left, and it would look like that, 0.23. Good. All right, next one. Write the decimal as a percent. Okay, so we're going decimal to percent. Decimal to percent, we need this, which is to times by 100 or move the decimal place 2 places to the right. Okay, so 0.085 times 100. 0.085 times 100, we get 8.5. And we were trying to make a percent, so we put a percent symbol. We could have also just moved the decimal places 2 places to the right. So here's our decimal right now. 2 places to the right, 1, 2, right here. We would have 8.5, which we don't really need the 0, so it would just be 8.5, which is what we got. Then the last one, write the fraction as a percent. Fraction to a percent, we're going to divide by, times by 100. So 4 over 5 times 100. 4 over 5 times 100. We get 80%. Good. 4 divided by 5 is 0.8. 0.8 times 100 is 80%. Good. Alrighty. Now let's look over some percent problems. Problems involving percent are called percent problems. 3 of the most common types of percent problems are: you could ask to find a percent of a given number. You could ask to find what percent of what number is another. That's like when you have a sale in the store, like 20% of 50, what's going to be the new price? Or you could ask to find a number of when a percent of it is given. Any of these percent problems can be used using the following formula: is over of equals percent over 100. So let's try this now. 16 is what percent of 50? So we have the formula is over of equals percent over 100. All right. 16 is what percent of 50? All right. Percent is what we don't know. So P is what we don't know. Over 100. Is 16. Of is 50. All right. Cross multiply. 16 times 100 is 1,600 equals 50p. Divide both sides by 50. P equals 32. Okay, let's look at the next one. Is over of equals percent over 100. Find 12%, so we're going to put the 12 in the percent part, of 420. We don't know what the is. I'll just put I. I times 100 is 100I equals 12 times 420 is 5040. Divide by 100. The is equals good. So 50.4 of 420 would get us 12%. Now you pause the video and try this. Alright, let's see. Remember, it is over of equals percent over 100. 12 is. So 12 goes in the is part. We don't know what the of is, so we put O. 75 goes in the percent over 100. 12 times 100 is 1,200 equals 75O. Divide both sides by 75. Of equals 16. So 12 of 16 is 75%. Alright, again, is over of equals percent over 100. What percent? So we're not going to know what the percent is. Of 55. 55 of 250. Alright, let's see. 55 times 100 is 5,500 equals 250p. To get rid of the 250, we are going to divide both sides by 250. We get p equals 22. Good. So 22% of 250 is 55. Oh, I'm going to put a percent, 22%. Good. All right, and let's do these word problems, and then we can wrap up this lesson. John made 6 baskets out of 30 attempts. So 6 over 30 equals what percent? The unknown percent over 100. So that would be 600 equals 30p. Divide by 30. P equals 600 divided by 30. 600 divided by 30. 20. What percent of baskets did he made? 20%. Okay, the next one. Steve told his dad that he won 80% of the game. So 80 goes in the percent part over 100. If he won 4 games, how many did he play? So of it is what we don't know. We don't know how many games he played. But we know that he won 4 games. So 4 times 100 is 400 equals 80O. Divide by 80. That's 5. So he played 5 games. He played 5 games. He won 4 of those, so that means he won 80% of the games. Good job. And that wraps up our lesson on recognizing and applying ratios and percents to real-world situations.